Hello everyone, welcome back to our prompt engineering series. I hope if you have joined us for prompt engineering 101 on our previous videos, you are already making this prompt engineering. I hope you have understood the TCPEF framework, task, context, and so on. And you have seen this various kinds of prompting, 0, 1, and few shot prompting, which will guide you in this AI. So today we are coming with deep dive into these prompt formats. So let's begin. Today we'll cover on these concepts. Just these are the foundational skills, but in an advanced prompting techniques. So here we have first we'll talk about this instruction prompting. Next we'll move through few short prompting, chain thought, and tree of thought, and next self correction. So these are techniques. Even I can term them as an strategic planning capabilities also for LLMs. So let's dive in. Initially, the foundation, that is instruction prompting. So you have gone through the difference between prompt and prompt engineering definitions in your previous videos. Now I would like to classify this thing instructions into two types. There are simple instructions and complex instructions. These simple instructions are which are straightforward and single step counts. Okay, first step. Suppose we can generate like summarize this text or translate this sentence into French. So the AI can typically execute these directly based on its own general knowledge. Whereas coming to complex instruction, these involves multiple steps or some conditional logic because it require AI to combine the several subtasks. For suppose, if we give summarize this text, then extract all key entities like names and dates, and finally present both summaries and entities in JSON form. This requires AI to orchestrate several actions based on single prompt only. As this involves a multiple steps, it is termed as an complex instructions. So these are two types of instructions. Generally, we are classifying on top. Next, coming to an two core pillars, which I would term as instruction prompting and the deeper utility of few short prompting. So here, let's have a quick demo of this example. When you run this prompt, Summarize the key difference between supervised and unsupervised learning in machine learning in exactly three bullet points. And expected output. In the prompt only, I am giving these text along with expected output in a bullet points. So these bullet points act as an placeholder, indicating that the actual output will be three distinct bullet points. Okay, this is how we are maintaining a clarity and directness of instructions to an LLM. Okay, why? Because to get an well formatted result directly, we are fulfilling the prompts required. Okay, this is known as instruction prompting. Technically, modern LLMs are instruction tuned only. This means during their training, they have seen countless examples of instructions which are paired with desired responses. So they are built to follow those directions only, whether it is a simple instructions or complex instructions. So how clearer you are with your instruction, then there will be a less room for misinterruption. Okay. So instruction in a prompt lead to precise and well formatted output for an LLM. That is for sure. That is how instruction prompting will able to define. Next, from that, I am moving to few short prompting here. Okay, what is meant by few short prompt that we have seen in previous video? Just to recap, we'll have a discussion on its definition. Okay, when we are providing an AI model with two or more examples of a task, means which have input and output pairs within that prompt itself. This allows it to learn the patterns. Okay, that will generate accurate results for us. That is that is simply defined as few shot prompt. Okay, here why we are talking about this now is this is also very incredibly powerful. When it is powerful, when there will be a task which requires a specific patterns to understand or to get a complex output format, we'll use this few shot prompting. Simply consider an example like give an input as an apple. The output you should get is an fruit. If you give input as an carrot, the output it should get as an vegetable. Now we will ask input is banana. What is the output? Here the AI will likely predict that it is a fruit. Why? Because it have learned from the patterns which we have given. What we have given? We have given input as an apple and output as fruit. Same input as an carrot and output as a vegetable. So this is how it will learn the patterns. Especially, what is the role of this few shot prompting in context learning? It is ICL. ICL means model learns directly from the examples which we are provided within the prompt. Without need, they don't need any external fine tuning or retraining. Okay. When LLM processes our prompt, it treat these examples as a current working memory or context, so that it is able to find out the relationship between the input and output just like a humans do. Okay, that's how it plays an in context learning. Next, talking about this, AI identifies patterns from examples within the prompt. How this is doing? See, based on its vast pre-training, the LLM is incredibly able to recognize the sequence or structures or any relationships. But even though when it sees that okay, input is apple, output is fruit, and followed by input is carrot, output is vegetable, it starts to infer this rule or it starts to mapping. It starts mapping. Internally, the model extracts the relevant features. For these examples, like for apple, it might activate concepts which are related to fruits. When it sees banana, it recognizes similar features and applies the what it have learned from that mapping. So it's still predicting the most probable next tokens. So that is how AI is able to identify the patterns within the prompt only. It is not included in training or anything. Okay, within the prompt only. Next, when to use this few short prompting is here. I have identified four things. When there is a complex classification, when you are confused with the complex multiple things, simply mention with that input and output, it will only recognize the or it will able to classify easily. And when to extract and specific data, which is an structured data extraction, or when you want a specified formatted output, style replication, or handling edge cases. These are the cases when you are going to use this few short prompt. Okay, let's look with an example so that it will be more clearer. So, few short classification. This is a special way uh, we use our few short prompting where our goal is to categorize the new inputs based on some predefined classes. Okay, based on those labeled examples only, it will understand the patterns. You may get a doubt here. We have discussed few short prompting, and now we are talking about few short classification. How these are both are differ. See, when a few short prompting is a technique of providing examples for any task, whether it's summarizing or translating or generating code, even classifying. Also. When come to few shot classification, this is a specific type of that task categorization. Okay, that leverages this few shot prompting technique. Got it? That it is an application of border method. If you see here in this prompt, I have gave classify the following customer feedback into one of these categories. That is feature request, bug report, and general inquiry. This requires some understanding from the AI, right? So notice here we have provided very clear three examples. Either one of the bug report, one of the feature request, and one of the general inquiry. Each example shows some kind of feedback, right? And I want them to categorize into some category. Okay, when we are giving a feedback. The app crashes every time I open the camera. So, from this feedback, what it is defining, we are categorizing this feedback into a bug report. And so on, we provided three feedbacks for this one and asking for the fourth feedback. And we are asking to classify that one into some category what we are given. So when we give this AI a new piece of feedback, which is not included in the examples, then the new dark mode feature isn't working correctly on my device. Then that AI doesn't guess. It looks like it looks back again. It will go back for these examples. What we given prompt. So it sees that app crashes every time, which is mapping to bug report categorization. So it recognizes that dark mode feature isn't working correctly, where it can recognize the semantically very similar, that is crash. I mean crash. It's an some kind of malfunction. So it's not a new idea or new thing. Just a simple question. right? So this is how it will understand the patterns and provide a answer. Next, moving on, we are moving to chain of thought, that is COT. This is one of the same advanced prompting technique. Okay, these techniques will instruct the LLM to generate sequence of intermediate reasoning steps before getting a final answer. For suppose if you ask, if a customer buys three apples at 10 rupees each and two bananas at 50 rupees each, what is the total cost? So then this COT will calculate this step by step. First, it will calculate the cost of the apples and then cost of the bananas and then it will sum up. So this technique is how these LLMs approach the complex problems. When you got a complex problems, we'll able to see the reasoning behind uh, before giving the answer. See, instead of just asking for an answer, we are instructing the AI to think step by step and show the reason. Yes, it will show the reasoning steps. Just like think how you solve math problems when you're in a schooling age. You don't just blurt out the answers. You break it down and perform some intermediate calculations, and then you get into a final answer. Same COT prompts also encourages the AI to do the same. That is the chain of thought. It will give think step by step. Why it will work? The question rises. Technically talking, the COT works by forcing the LLM to its internal reasoning process. Okay, these intermediate steps help the model to stay on track. Sometimes maybe there will be a deviations or missing any information. But this chain of thought will maintain a track and significantly improves our accuracy also. So, how I am justifying this chain of thought is it externalizes the reason. Yes, this means LLM will have a thought process and making its internal logic also visible to us. Okay, this transparency is very helpful for debugging or understanding how the model arrives at the solution. So when a AI engineer or ML engineer will or developer who is working on developing LLMs, they will able to debug this by using chain of thought prompting. Next is reducing hallucinations. Yes, by breaking down the complex problem into smaller verifiable steps, this model is less likely to generate incorrect information also. Each step builds on previous one, so there will be always a connection. Okay, next improves accuracy for multi-step logic. For for the task like which requires multi-logical operations. The COT allows the model to process each step sequentially, right? So this prevents the model from trying to jump directly to the complex answer, which will increase this accuracy also for multi-step logic. Next, it provides more thinking tokens. Yes, by generating an intermediate thoughts to the user, here the model uses the more of its context window for reasoning. This extends the internal processing space and which can lead to more accurate solution, especially for the problems which require a deeper contemplation, such like a scientific approach computations. Okay, and the inner monology, which is very essential for this LLM generating its own thought process, as it's a part of its output, so that here the chain of thought it will guide the LLM towards a more accurate final answer. That is the importance of chain of thought. Next, moving on, zero shot chain of thought. Here, what is meant by zero shot and chain of thought? We are combining these two techniques. As we know, chain of thought is where the LLM is simply prompted within the task, and that task we also include the phrases like let's think step by step without providing any examples for reasoning. Next, coming to zero shot. How it differs from zero shot? For few shot or zero shot, it will teach us the model desired reasoning pattern through demonstrations. Yes or no? Through examples, what we prove. But combining these two or integrating these two, how will help in prompting? If you look at this example, if a car travels at 60 meters per hour for 2 hours and then at a 40 meters per hour for 1 hour, what is the total distance travel? Let's think step by step. And if you see here, this is the expected output with reasoning. Why? Because why it is providing reasoning? Because in the prompt we have mentioned that phrase like let's think step by step, and no examples provided here if you observe in the prompt. So when you run this without seeing an example also, how it is getting a reasoning? The LLM understood the instruction to break it down, which is also leading to the correct answer and clear explanation. This is how zero shot and chain of thought combines and integrates this prompting level. Next, we will combine few shot and chain of thought. Few shot and COT. How this will be? Same chain of thought where the prompt includes multiple examples that we'll know which have input and output with each example. Okay. Now, if you see this example here, with, when we are giving a question, what are the intermediate steps it has? It will generate that one, and then only it will go move to a final answer. Yes, sir. So here, this teaches this AI how to think for specific problem or specific problem types. Here, the zero shot CO2 completely or purely relies on LLM's abilities only to get these reasons or reasoning steps. Whereas a few shot COT teaches this model with the desired reasoning patterns through demonstration. So if we observe, this makes a more accurate for specific task, for specific prompting. So few use this few short COT for complex logic puzzles. Like when you need AI to follow a very specific reasoning pattern, or for a task where the steps might be an various from our thought without the guidance. Okay. And I also mentioned here when to use this is when more complex logic puzzles, specific reasoning patterns, and ambiguous steps. Moving on. Yes, here the tree of thought comes. Behind the chain of thought, we will discuss here tree of thought, TOT. We know that chain of thought is fantastic. But what if a problem has multiple possible paths to a solution? Or what if it requires exploring different ideas before committing something? That's where this advanced technique, tree of thought, comes in. This is an advanced extension of COT. See, instead of single linear chain of thoughts, AI generates a multiple possible thoughts or reasoning steps at each step. So, if then it evaluates these paths, that potentially it has to go back and explore new branch, and then it have to take a decision. For example, if asked to plan a meal, it might generate this Italian or Mexican, Indian, or evaluate each, choose the best. This is the prompt which we give. Mm, Okay. So we are asking to choose the one what we wanna plan for our meal, either Italian or Mexican or Indian. Evaluate. It has to evaluate each one, and then among that one, it has to choose the best. Here where the COT fails and TOT arises. And next, why it works? Yes, I have a clear explanation for this also. Which exhaust search for problem space. Just a second. Yeah. So here TOT allows the model to explore a wide range of potential solutions and strategies rather than committing like a single linear path. This significantly increases the finding the best way or highly creative solutions. We can use this tree of thought. That is the first thing because we are increasing the problem space. Next, better for complex planning and creative problems. Of course, for the tasks which don't have a single solution, like a strategic game playing or complex design challenges or multi-facing planning also. Where this TOT enables the AI to brainstorm and wade through different options. And next allows brainstorm and critique. Yes, this model can generate several ideas. Ideas in sense several thoughts, and then critically evaluate each one against each specific criteria which we give. So this process simulates and more human-like decisions, okay, where the options are considered and refined. I have given to choose three different types for our meal: Italian or Mexican or Indian. Which one is better? It should go through each path, then it should come back, and then it have to choose the best. So we have three branches here: moving, coming, and backtracking through that one, and choosing the best. So here where tree of thought comes into picture. Moving on. Self correction or reflection prompt. What is mean by this one? A multi-turn prompting technique where these LLMs are instructed to review its own generated output. How it will? That is comes under like self-correction or self-reflection. When we give a specific criteria, it should identify errors and where the areas of improvement, and it have to generate the output accordingly. For suppose, if you give the sun is hot, and I'll mention here is review it or revise it. What it will self correction will do. Whatever the input is given, it will go through the semantical or semantic meaning of each word grammatically. That involves multi-turn interaction with AI, which reviews its own output. So the initial output, the sun is hot. You might ask it to review, and what it will give, sun is hot. First thing we have give the sun is hot for suppose. Then it will revise that one and it remove the sun, the e from the sentence, and it should only give sun is hot. Okay, don't worry, we'll move on and we'll see more examples so that it will be more clearer for you. If you see here in this picture, I have mentioned asked AI to write some short email, but I want it to be more concise and professional. So what I gave, write an email to colleague John about upcoming project meeting on Friday. Tell him it's important. Okay, now I'll give a self-correction prompt. When we rerun this one, where it approaches the multi-turn system, this allows to guided AI to rework on what it has generated. Just it is like an acting as an editor, I suppose. So by it ensuring the quality, it is a high quality for the task. And how this helpful for us? It refines us based on criteria or new information. Yes. And why it works is AI acts as a generator or critic. Yes. This technique helps the makes LLM to act as a dual capability to produce a text and evaluate it. So it effectively simulates this human ability to review and refine their own. Up to now, what we have thought, though AI technology is moving on, still we need a human to review the things, at least. Here, this advanced prompting technique, which is enabling the LLMs to review its own work, that makes a more accurate results or more autonomous systems also. Next, it enables iterative refinement. Yes, it creates very powerful feedback loop where this model can learn from its mistakes or what are the areas for improvement within that current session. And this allows for progressive improvement of output quality. When you have a multiple turns or multiple steps, it will generate quality output. Next, it ensures high quality polished outputs. Yes, again, same point. By explicitly guiding the model to check against this specific criteria, whatever the professionalism, whatever the accuracy or self correction, this helps to produce highly polished and precise final responses which meet our requirements. So that's why if you see in this output, I have asked for a more concise and professional email. And you can see the output clearly, how concise it is, right? And yes, we are moving to the end. So we have covered a lot today, very important and advanced things like from reinforcementing these power of clear instructions, types of instructions, and few short examples, and deeping dive into the capabilities of the COT chain of thought. And we have seen tree of thought, and finally coming to self correction also. So these advanced prompting techniques are very truly evaluate our ability to interact with AI models and to control AI models. So here interacting and making, accessing and controlling the AI models will all comes through prompt engineering only and only. Okay, because that is why if they allow us, like we we are making LLMs to solve very complex and logical problems, right? And they are performing like high accurate and also making classifications and guiding AI in multi-step planning and in self-correction, ensuring the AI outputs are polished and professional. So this is how the if we know prompt engineering basics and these kind of little things, I can say these are only a little things in whole AI. If you know only these little things, we'll able to control the AI models according to us or according to our theme, what we have. That's why prompt engineering is rapidly evolving the field. And mastering these kind of techniques and putting art into an experiment, giving a cutting edge technologies. So here is a task for you. So I would like to ask, what is the complex task you have excited to try prompting for? What is the complex task you are excited to try for prompting? Just let me know in comments below and keep learning, keep interaction with us and learn more and more and wait for our next videos on prompt engineering. I'll see you next time. Thank you.